Hi, this video is about the formation evaluation and the value logging, especially on the Picketts plot. And the reason why I have recorded this video is because I find that online is very difficult to find the resources. So that's why I have this video after I've spent a lot of time to study on this. And yeah, this is very shit. Okay, so we go ahead for the exam question. So let's say the table one shows that the data resistivity of the blah blah blah, right? These are nothing quite important, and because we want to plot it out, because for exam we need to plot this thing, the Picketts plot, right? So we just need to know how to plot it up with the information given. So we just need to plot a graph of this one, the sonic versus the resistivity, okay? And the question A and B, I don't cover here because this is what you can find on Google. It's very simple. You just find it and you know the answer. So what it focuses is on the plotting on the graph, straight to the point. So we need to plot up a graph like this by using the Picketts plot technique. And then given, okay, so this is important, this thing, given the water resistivity, right? This is very important. All right, let me highlight this one. All right, we will use this one, a big red color. And average porosity is this one, all right? So we are using these two things. Okay, let me show. Before this, I was interpret these two as the same thing, right? Like a point, x and y axis, but actually they are two separate things. Okay, so RW, this one is when we plot on the graph. It's 0.01, sometimes 0.015. Let me show. Okay, so remember this number, 0.018. So means that when we plot this one, right? So this is for the RT, right? The axis is the RT. Well, and for the Y is the porosity. Okay, so if given the table is this one, is the resistivity over this sonic. I think there's some problem for this one. Okay, it should be maybe in terms of percentage instead of this one, because when we plot is against is percentage over the resistivity, it should be like that. Okay, this should be the x-axis, this should be our y-axis. Okay, then we plot this thing. All right, let me go back to the RW we have found. Okay, right here. So if given that the RW is equal to 0.018 ohm meter, all right? So first you need to know how to read this scale. Okay, so you can see 0.1 here and 0.1, 0.01, sorry. So you can see that this is quite wide and getting small and small and small and small and small. But actually, we read as, okay, this is 0.1 and this is 0.02. And this is 0.03, 0.04, 0.05, 6, 7, 8, 9, and 10. All right. And same for here is 0.2 and so forth, increase by 1. Because here got 10 boxes, all right? So no confusion, and 1 and then go to 2 and 3 and 4 and so forth. And from 10 become 20 and 30 and so forth until 100, okay? So you know how to read this thing already. All right, so yeah. And this RW is from here, okay? So 0.01, this is 0.02. So it should be in between here, right? So it should be a straight line, something here, 0.0, right? So this is 0.018. So what given here actually means that when I plot this kind of graph, this thing is important where we start our point here, right? Where this is 100% porosity because assume like this is water, totally at water. So the porosity is 100%. So we start from this point where is 0.018, right? This is one important information. And the next thing, given the average porosity, the average porosity is 70%, right? So this another important message is we need to find out the 70% This is 10, and this is 20, and 30, 40, and so forth. So it should be in between here. Let's say something here, because over this 70%, right? And then from here, I need to draw a line. First, right, draw this line. Okay, this is 70%. Draw a straight line. This is the 70% over here. All right, cool. And then the next thing is need to plot out all the graph here. Let me show you one because I already plot, because it really takes time to put it every one thing. Let's say we look at this one, 0.4 and 20. Right, 0.4 and 20. Right. I draw small here. Okay. So 0.4, as you can see, 0.1, 0.2, 0.3, 0.4 here. All right. And then how many percent? 20. All right. This is not microsecond per feet. It should be percentage. I think it should be the porosity based on the sonic. All right. It shouldn't be like this. It should be in percentage. Okay. There's something wrong with this question. Okay. Never mind. But the first point is 20. Go ahead to find 20. All right. 20 is here. This is 10 and this is 20. All right. So the intersection between, and this is the point. And so forth, we plot all the points from the table here. All right. So again, try this out on your own. All right. So once you try out, you can come back here again. You can look at this table. Okay. All right. So right now we come back here. So let us continue for drawing. And normally, and the next thing is what we want to draw is a line. All right. A line from just now given this point. All right. You need to draw the line of best fit. If you still remember, what is the line of best fit? Line of best fit means that you have to touch as many points as possible, but the separation for a point that doesn't touch is not so much, just very near to each other. All right, so here I draw one starting from here. This is very important. Is we given that 0.018. Sometimes it's 0.15, so we plot over here near it. All right, but right now it's 0.1. We start from this point and then join here. Okay, we join the point that's nearest. We try to join as many points as possible. I draw here, I can join almost like 3 points very near. So this should be a good estimation. So this is my point. Right, this line is where we have the 100% water saturation, the saturation of water, subscript water. All right, this 100%. All right, and then we have to draw the continuous line. That because we go back to the question itself, it say that it is something like assume m equal to 2, but this is like you need to take care of it because this is a gradient, right? This is about the same gradient. Everyone have the same gradient, but it's because the formula is a negative, it should be the negative gradient. So it's like the graph is going here, so it should be fine. But you can just ignore it. It doesn't anything. So here the question C, D, E, F, G actually is the whole question here from C to D. Actually, these are from, we plot the graph and then we got everything here. So we just plot it up and then we just answer all this question will be fine. Okay, so you see like a lot of questions, but all questions is related to how to plot a complete graph. All right, so no need to worry. So we go ahead back to draw the complete graph here. Right, then go up. Okay, and next, okay. So I just delete it first. It actually doesn't exist over here. I just put it myself. And next thing we need to have different points. All right. So normally we have from 2 to here. Normally we will have taking 2, 3, 5, and 7. So you ask me why, but I'm also not sure why, because most of the answer will take for us. This is the first line, and the second 3, 5, 7, and 10. So we have 5 different percentage. we have like, for example, this is not accurate. Like for example, I have different line here. So it represents different percentage, maybe 51, 30 something, 20 something, 16 something, different percentage of water saturation. All right. So yeah, that's why we have to use the resistivity given here. All right. So normally it should be 2. So we have a point here, 2. Right, 2. And then we have 3. And then 4, 5. 5 here. Not so nice. 5. 6, 7. All right, 7. And 10, the last one. Right. So we have 2, 3, 5, 7, and 10. All right. And then how we plot the graph, actually, we should have the same gradient. So if you are using the real graph to draw it up or not, then you can copy the line. Maybe let's say I use the PowerPoint line instead of this line because I cannot copy. So let me insert the line. Right. I draw one line, touches as many as possible. You can see my line. Make it thicker, right? Black color. All right. Then I can copy this line and paste this line because I need to have the same gradient. So I shave it up. All right, until it touches the point. Okay. So when we find it out, I have copied this line. We have to touch it at this point, the intersection between the 17% of porosity and the 2 resistivity. All right, this is what I fix here. All right, and yeah, and touches here as well. And from this line, we no need to be so long. We can be until some kind here will be enough. Okay, so yeah, just like that. Okay, and then we continue. We have done for the 2. Then we go for the 3, 5, 7, and 10. We just copy the same line, copy and paste, and I move, shift until there. All right. It's good enough. Then I make it short. But when you use a ruler, maybe easier a bit. All right, and then again, copy this line and paste. Touches the 5 and so forth, and the 7 and the 10. Okay. Now if you're drawing the real graph, maybe you can use eraser just to erase it. Make it shorter, then it looks nicer. Like area just cut like this, make it nice. All right, we've done all this. Then we need to calculate how many percentage. All right, this is a very tricky part here. So this one has a formula, water saturation, and yeah, it has like something like A RW over square. This should be M and RT, and this is N, right? So like quite complex, but actually normally we assume M is equal to N is equal to 2, right? And A is equal to 1, so it means like we don't have the A, where M become 2, N also 2. N also to be a square root, right? Square root, normally we don't have the 2 here, so we don't need to write the 2 here. So normally it would be just a simple form like this, all right? This is most of the cases. We'll be using this like this, all right? But in this Picketts plot is not in this case, right? But you have to consult with your lecturer. Some lecturer might need you to find what is the A. Some might just assume this is 1. Okay, but some textbook is not 1. We have to find out. So remember, very important that in this case, Picketts plot, whereby A is not equal to 1 actually. All right. Because if A is equal to 1, it doesn't satisfy this equation. 100%. It might be like this is 51%, something like those are constant that you memorize and then it paste it, but sometimes it just kind of doesn't make sense. So the actual problem is because the A is not equal to 1. But some lecturers just say, just A equal to 1 is okay. But A is not 1 here in this case. We have to find what is A. We have to calculate it and put it here. So, okay. So remember, A is not equal to 1 in this Picketts plot. We have to calculate. So for this case, we have to calculate ourselves as well. So for this line, as you can see, this line, then we have to find out where SW, 100% it means 1, square root of A, we don't know. RW is always constant in our calculation. We use this one, RW, water resistivity. And porosity, 70%, so, but not 17, it's 0.17 square. And RT, so we can look at here. What is our RT here? What touches this line? For me, here is 0.8. Yours might be different because slightly difference on the plotting. So mine is 0.8 here, okay? And square root. Then I can find my A. All right, you can use the calculator to find out. And my A I find is 1.28. Okay, this is my A. Your A might be different now. Okay, but you can see it's not 1. Okay, then we put it here, 1.28. And we use this value to calculate the next line. And so for this line, what is the water saturation here? Okay, then substitute lah. The value is 1.28. RW is constant, 0.018 over 0.17 square. RT here is 2 because we fix it, this is 2. And then square root, what you find? The water saturation here is about 63% for my case, 0%. And we continue to find the next line, and next line, and next line, and also the next line. Okay, then you can try it out yourself and double check whether our solution are consistent or not. Okay, so mine is 63 and 22 and so forth. I type it up because my handwriting is not so nice. Okay, I admit it. So, and yep, this is how we complete for plotting the graph of this Picketts plot, and then we can go back to see what the question wants us to find. Okay. Right. So it's a plot the data, we already plot it out. Okay, and identify the 100% saturation line. All right, where M is unknown. Okay, the 100% line is this one. This is the 100% line. This line. This line. Okay, so this is 100%. You just label it 100% water saturation. Okay, cool. And see next question. Outline 5 different percentage of water saturation. Right? As we already did it. Okay, we have 5 here. Different, like 1, 2, 3, 4, 5. We already plotted 5. Okay, normally it's 2, 3, 5, 7, and 10. Okay, already done it also. All right. And F, reservoir often considered productive if water saturation is equal or below 50%. Okay, so from the plot we have, identify how many zones are considered commercially exploitable, which is has been less than 50% or equal. So let's see here. Okay, so this is 50%, so means 40% okay lah. 34, 28%. These 3 are okay. Means these 3 are okay. This 3 zone. Maybe here also okay because not yet 50, right? 50 also. There's 1, 2, 3, and 4. These 4 zone. Maybe I can like highlight it like this. Hey, fill. And then the line is the dotted line. It's not so big, not so obvious. Then rotate it. almost not yet 50, but within these lines are okay. Right, this might be good. This zone, the zone before 52 was okay. This area, okay. So we drag this, and we look at the next question. Deduce which zone has the highest oil saturation. Of course, the lessest SW lah, because S oil is 1 minus SW. Means like one thing 100% is 100%. If this is 20%, then this is 80% lah. It's either water or oil only. So the lesser the water saturation will be, the best of having the highest oil saturation will be the last line, the latest line here. Okay, so will be the last line lah. This is this line, the line with 28%, if it's the highest oil production. Yeah, and that's it for the Picketts plot. All right, so yeah, hope you learn something and it saved your time.